sorry. Hello, everyone. Welcome to all our participants from the CNMI and Guam. I appreciate you guys joining our training today. Today's training will be on collection systems. It'll be our third part in our collection systems webinars, and this one will specifically cover maintenance. I will be your primary trainer today. My name is AJ Barney. I'm a research engineer with the Southwest Environmental Finance Center, and we are joined by Valeria Cortez Mora. She's our professional intern, and she's going to be handling the chat and all of the logistics for the training as well. So if you have any questions, feel free to put them in the chat, and she'll try to relay them to me, and we will try to discuss those. Real quick, I know many of you guys have been to our trainings already and are familiar with this, but for those who don't know, we are the Southwest Environmental Finance Center. We are part of the UNM School of Engineering, and our training series is funded by the EPA. If you have not used Zoom before, you do have a control bar that allows you to do things like start and stop your camera and microphone. You can change your background. You can also share, chat, send little emojis that you like and stuff like that. So here's just a kind of brief overview of what's on there. If you have any questions, again, enter them in the chat, and Valeria will try her best to answer them. Now, as many of you guys know, these trainings are based on the Water Professionals International, what they call their ABC operator certification. This is a pretty standard guide that is used to assess wastewater operators. Many of our topics are specifically aimed at helping you guys pass your wastewater operator level 1 and level 2 exams. If you are interested in more information about this exam, information can be found at their website at Water Professional Internationals under the wastewater operator section. So we are currently, this is our recent schedule of trainings. We are currently here for September 16th in the collection system maintenance training. We are going to continue training these or providing these trainings for the rest of the year and into next year as well. Finally, if you want to see recordings of these trainings, they can be found at this web address at the Southwest Environmental Finance Center's webpage in the Cert training tab. And then just as a final reminder, make sure to sign in if you are attending in a group, and sign in into the attendance form, that is. And then the facilitator at your location will go ahead and make sure to forward that information to us so you guys can go ahead and get your credits. Now with that, I'm going to go ahead and start the training. And the first thing I want to do is kind of just ask a simple rhetorical question, which is, why do we have to perform maintenance on our collection systems? So to answer that question, we kind of show our little broken manhole there. And the first answer to that question of why do we have to perform maintenance on our collection systems is that, like with any wastewater infrastructure, as use goes on, that infrastructure tends to degrade over time. It wears away, things get old, things break, parts get lost, stuff like that, etc. But then also, specific to our collection system, many people, the users that use this collection system kind of treat the things like that they flush down the drain as out of sight, out of mind. Now, both, people don't really think about what they flush. We've seen things like wipes. We've seen, people put trash down the toilets. People put rags down the toilets. So all kinds of things. So because of this, our collection systems need constant attention. So that's both preventative and corrective maintenance. Now, all of these are required to make sure that our collection systems do not fail. They are to ensure that we do not have overflows, and they can protect the public health. Maintenance also ensures that we meet our regulatory requirements and that we are not violating based on overflows or based on a lack of maintenance. Maintenance also helps extend the life of the infrastructure that we build and that our users pay a lot of money to be able to have access to. And then also, if we make sure to have good, strong maintenance schedules, you can prevent unnecessary emergency costs. Emergency costs are going to come up no matter what. However, if we can do, have a good maintenance program, we can prevent excessive ones and unnecessary emergency costs. So the first thing I want to talk about is some categories of the most common collection system issues. And these are the ones that maintenance target, and we consider kind of 4 categories. These are going to be obstructions, structural issues, environmental issues, and infiltration and inflow. Now, these categories can intersect, and infiltration and inflow is typically a result of the others. But in our next couple of slides, we'll kind of go into a little more detail of what each of these are specifically, what they are in a vacuum, and then what are the problems that can result from these issues if they are left unaddressed. So the first thing I want to talk about is obstructions, and for this slide specifically debris, because there are a couple different kinds of obstructions that we kind of take into account. So debris can be just incidental, or like I mentioned a little while ago, because sometimes our users treat the wastewater system as out of sight, out of mind, or more commonly kind of like a trash can. Then the mindset is kind of, anything that goes down there belongs down there and it's gone for good. So with that in mind, debris is kind of classified as any unwanted solid material that enters the wastewater collection system and can obstruct or impair the flow. So examples of this would be trash, which would be rags, wipes, which are marketed as flushable, but they're not, and so that's why rags are, wipes are kind of a notable one. Plastic, rubber, paper, that kind of typical trash products. So, with that topic of trash, everybody I know who works in wastewater knows there's tons of rags in the system, but I've never quite found anyone who knows how they get there exactly. But they're always there. So that's kind of shows the ubiquitous, that kind of like omnipresence of trash in the collection system, because for some reason stuff always gets in there. And then, like I said, those non-flushable wipes are those pesky wipes that are marketed as flushable, that those companies say are flushable, but they don't decompose and instead tend to combine with other debris and clog our mechanical systems. Now, we also have grease and fats, which come primarily from washing dishes used for food preparation. Then there's sand, grit, gravel, construction material. That's kind of going to be anything that can break away from the collection system itself and end up as debris in the collection system and cause blockages. We will talk about more about, how those lead to structural issues as well later on in the presentation. Then there's also leaves and sticks that end up in the pipes. That those kind of from wherever and kind of fall in manholes and work their way in between creases and stuff like that. And then finally, the last kind of debris obstruction is going to be excessive wastewater solids, which would likely be things like fecal matter that kind of gets stuck in the system when it's not designed properly. Now, the second obstruction I want to talk about are root intrusions. So root intrusions happen when tree or other types of plant roots grow into the pipes of a collection system. Roots enter through small openings, such as cracks, broken joints, or poorly sealed connections. Now, just kind of the basic biology of roots is that roots tend to, and why they become such a problem, and why they're kind of ever present in our collection system, is that roots tend to gravitate towards weak spots in the pipe that are kind of either already leaking, or they have condensation, so those plants kind of naturally seek out that water and collection system infrastructure, though they're kind of the perfect target for that kind of that behavior where they're kind of seeking them out due to those leaks in the condensation. Now, once they kind of breach that infrastructure, they can grow quickly, and because the environment is moist and full of nutrients, they can grow. And as they grow and expand, that can make those issues of them growing in the system worse. And they can even act as sites for other debris to cling onto. It can act as sites for debris accumulation. Now, roots are more likely in certain conditions. This is typically going to be such as old and deteriorating pipes, which are more likely to have existing cracks and joint failures. There's also clay and concrete pipes, which are more likely to have weak points that are more susceptible to those root penetrations than more modern pipes, such as PVC and HDPE. And then the one more is the dry soils. Typically, those dry soil conditions can cause plant roots to grow more aggressively in order to locate moisture as well. So a lot of times when you have sewer pipes in dry soils, they can have a high chance of having those root intrusions. Then the final condition that can cause more root intrusions is just going to be areas near vegetation, especially in trees and shrubs, which when planted near sewer lines, they have those stronger roots that can penetrate them and create a higher risk for root intrusion. So those are the two kind of root intrusions that we're going to talk, or I'm sorry, obstructions that we're going to talk about. Now, the issues that they can cause, both obstructions are a concern because they can cause a range of different operational and environmental issues. Obstructions can cause blockages and backups, which are known as sanitary sewer overflows. Debris specifically is known to cause pump damage as well, as those solids, like we talked about, the grit, rock, pieces of trash that are really sturdy, can damage impellers or clog pumps, which can lead to mechanical failures and costly repairs in the system. Now, both debris and root structures can lead to reduced flow capacity, as obstructions in the system tend to narrow that pipe diameter, which can reduce the hydraulic flow or hydraulic capacity, increasing the risk that those systems or those specific pipe sections can have overflows during peak flows. Now, also obstructions are important because frequent obstructions can also lead to increased maintenance costs due to frequent need for cleaning, jetting, and emergency responses, which can drive up those operational costs. And then the final issue with obstructions is broken pipes. This is kind of mainly due to our roots, which will grow in there, and as they grow, they make those cracks wider and cause collapses and stuff like that. So how do we address those obstructions? A lot of times this is done through routine cleaning. This can be done through things like hydrojetting, where high pressure water is used to clean out debris, mechanical rodding, where you have a rotating cable with cutting tools that can scrape and remove buildup, and then also vacuum trucks, which can be used to suck out the debris from those manholes and basins where the obstructions can collect. Then another way of addressing obstructions is frequent inspections. You can use things like closed caption television or CCTV cameras that you send through the pipes to locate and assess blockages to kind of create some more direct cleaning. This type of inspection can help determine if cleaning or repairs are needed. Then there's also public education. So if you kind of inform your users about some of the dangers of blocking the sewer system, that can possibly help reduce the flushing of non-biodegradable items or improper grease disposal as well. Now, specifically to address root intrusions, you use things like mechanical removal, where you use things like root cutters attached to rodding machines or jetters that are physically designed to cut and remove roots. You can use chemical treatment. These would be things like foaming agents that are designed to kill the roots but not harm the rest of the plant, but they do prevent further growth and regrowth of those roots. Then there is pipe repair and replacement. A lot of times when you have roots, it creates kind of severe damage, cracks that are not able to easily be repaired. And you can do things like, completely remove the pipe or replace sections of that pipe. And then also to just limit the exposure or risk of these type of issues in your collection system, you can also just turn to correct planning and design, like using root-resistant pipe materials, or avoid planting trees near sewer lines so that roots won't even grow near them. So that's kind of what are the issues and examples of obstructions. Now, the next issue that we run into a lot in our collection systems are going to be those structural issues. Structural issues in sewer systems are problems that affect the physical integrity of the pipes and related infrastructure. Now, just like obstructions, these issues can lead to system failures, environmental hazards, and costly repairs. Some example of these include things like cracked or broken pipes, which develop due to age, ground movement, external loads like traffic, freezing and thawing during seasonal changes, or those root intrusions that we mentioned. Now, cracked pipes tend to allow things like infiltration of groundwater or exfiltration of sewage, which can lead to environmental contamination and reduced pipe capacity. Then the next type of structural issue is collapsed lines. These are essentially the advanced forms of cracked and broken sections of pipes. A complete or partial line collapse can result in increased flow obstructions and even complete blockages. Another similar type of structural issue is deformed pipes. These consist of deformities that change the original shape and size of sewer pipes. This consists of deformities like buckling and bulging or swelling, which can tend to be caused by improper installation, shifting soils, excessive surface loads, and environmental factors like thermal expansion. So kind of, again, that seasonal change. Now, obstructions like root intrusions tend to aggravate those deformities found in pipes. One specific type of deformed pipe that we run into a lot is line sags. Line sags tend to create low points in sewer lines. They can create a perfect storm of all those issues where you have hydraulic issues due to backups, you have areas where debris can accumulate and slow down flow, and they kind of come together to cause overflows. Sags and lines do require constant maintenance and can be a huge headache for lots of systems. There are also things like pipe misalignment and offset joints. An offset joint is a misalignment or separation in the sewer joint that results in leaks, soil entry, and increased risk for root intrusions. A lot of times they're caused by, again, shifting ground and poor installation. Now, the final issue that we tend to run to is just issues in manholes. And manholes tend to experience those same kind of issues and are caused by similar problems. And it kind of usually depends on the condition of the manhole. And for a lot of these type of issues with like manhole issues and structural issues, the segments or whole lines have to be replaced to correct them. This is specifically what one of those type of issues might look like, a pipe sag. As you can see, it's kind of a dip in the ground where water settles and debris settles as well. And this has to be cleaned or else it can be worse. So the next type of issue will be environmental issues. Environmental issues in the sewer system consist of chemical and biological issues that are typically the result of untreated waste or poorly managed sewer systems. Examples include things like corrosion, which can be things like sulfuric acid, which forms when in anaerobic environments because microbes will use sulfates when oxygen is not available, and that creates hydrogen sulfide gas, which can create hydrogen or sulfuric acid at the top of sewer pipes. Especially just when that hydrogen sulfide comes in contact with moisture. And when it occurs at the top of a sewer system, it's called crown rot. Now, something similar to that are odors, and odors are also the result of microbial activity, and gases that are frequently a concern due to that microbial activity are things like hydrogen sulfide, which smells like rotten eggs, ammonia, which is both strong irritant and can be toxic and even deadly at higher levels. The same for hydrogen sulfide. Then there's also methane, which is actually tends to be an odorless gas, even though I'm bringing up odors. But the reason this is a concern is because, again, it's a gas and it's highly combustible. Then the last environmental concern is sanitary sewer overflows, which we've kind of touched on in a couple of our slides, but should be considered an environmental concern as this exposes the public and the environment to untreated wastewater. This is harmful because it can lead to the contamination of surface waters with toxins and excess nutrients. It can increase the exposure of disease-causing pathogens, and is harmful to wildlife, especially wildlife that lives mostly in those surface waters. So we will talk more about managing sanitary sewer overflows and emergency responses a little later in our presentation. Now, most of the time, environmental issues are prevented in sewers up front by having proper design standards so that dead zones are prevented, and also by putting in place best management strategies and practices that provide frequent inspections and maintenance to make sure buildups are not occurring that can cause overflows or provide stagnant environments where the microbes we don't want in the system tend to thrive. Now, a lot of times it's also useful to utilize corrosion-resistant materials, specifically to prevent corrosion. And with many system issues, a good educational outreach program can help inform citizens and users so that they understand how to be good stewards of the system they all use and kind of benefit from. So the next issue that we'll talk about, the last one in sewer systems, is inflow, which is when water kind of flows in from open areas. This could be like rainwater or storm water, and it is water that kind of inflows from manholes and other types of connections open to the environment. Then there's also infiltration, which is a similar concept, but it's groundwater kind of seeping in through the pipes. This picture is a little blurry, but what I'm showing is kind of some older infrastructure that's made from bricks, and water is leaking in from all sides of this manhole here. So both of these are issues, and the reason is because they can cause hydraulic overload at the wastewater treatment plant, and they should be limited whenever possible. One other part that inflow can get into the sewer system is through illegal connections, where someone builds something in and doesn't get the right permit to access the collection system, and it tends to cause things like inflow. Now, in order to deal with inflow and you need to have a good program that identifies these issues. Some of those methods include late night surveys, where you kind of check out manholes to see if clear water is running during hours when people are most likely not awake and using the collection system, which would be like 2 to 4 a.m. So if you have a bunch of water coming through, it's likely that it's coming from a source other than domestic areas, especially if it's clear water. There's also that CCTV inspections that we mentioned, so kind of just sewer videoing lines. There's smoke testing, which this is an example for in the picture. As you can see, there's smoke rising from around the manhole and through the lid, suggesting that if water is coming in contact with these areas, it can likely end up in the sewer system. And then finally, you can also use flow record analysis, where you can kind of identify if there's sparks or spikes or water flowing when it shouldn't be, again, like you would a night survey. Now, there are a variety of methods to contain I&I. Now, these are mostly expensive because a lot of times you need things like a full pipe replacement. You replace sections of the pipe through things like slip lining or pipe bursting. You may use chemical grouting to kind of patch it up, or improve your whole sewer system to make sure that excess water is not around that can collect in the sewer system. These types of services often require outside contractors and specialty knowledge, so systems tend to have to kind of pay for that to make sure that they can get that. So those are all the issues that we tend to see in collection system. Now our next section is going to cover how we actually look for them. So this section is about collection system monitoring. So we'll talk about a couple ways and strategies that systems typically use to monitor the collection system and identify those types of issues. So the first are visual inspections. Visual inspections are a critical part of monitoring our sewers. They involve typically visually assessing the condition of sewer pipes, manholes, and related structures to identify defects, blockages, structural damage, and other issues that can affect system performance or public health. The first type of these visual inspections, the first easiest type of visual inspection is inspecting surface conditions. So by looking for signs of overflows, sinkholes, pavement cracking, or deformations, unusual wet areas, those can all be indicators that leaks or water is settling where it shouldn't be, and that maybe what's going on underground is kind of affecting what's going on at the surface area. Another example of above ground observations is things like odors, because that can also indicate something is going on incorrectly below the surface, even though that wouldn't be categorized as a visual inspections. Now, visual inspections are also important in helping identify illicit discharges. This may come in the form of unusual coloration, oil, or other chemicals leading from buildings to manholes or arm drains and missing manholes, kind of indicating that someone's putting something in the drain that's unusual. Now, the second place that I want to point out that visually inspect, and then the other type of visual inspection that I want to point out is visual inspections at manholes. So a lot of times operators can look for cracks, exposed rebar, or deteriorated concrete, which can suggest corrosion. And then there's also I&I, indicated by, like we said, water seeping through the walls or joints, or just those unusually clear flows, again, indicating that water is flowing when people are not necessarily using the sewer systems. Manholes are also a good place to look for excessive buildups or unusual things being in the system. Like in this system, this kind of has a low point in this manhole. If you look closely at the bottom of it, there's kind of a t-shirt at the bottom where the water should be relayed to the next section of the collection system. The next type of monitoring tool that we use, which I've kind of mentioned a couple times, is that closed circuit television. But here I can kind of explain a little more what it is and kind of show some examples. So closed circuit television is known as CCTV and refers to the use of specialized video cameras in sewer systems to inspect the interior of sewer pipes and manholes. Now, CCTV is used to inspect the interior of pipes for cracks, blockages, root intrusions, corrosions, and structural defects. And it's typically the most effective way to directly observe what's going on inside those underground collection systems. Now, current CCTV practices also provide video documentation for condition assessment and maintenance planning. So what this process typically includes is a deployment of the video equipment, real-time observation, and likely video recording of the activity or of the movement of the CCTV camera through the pipe. Then there is some reporting, which is during the recording process, you will take notes that can indicate where defects are, when they are, and what type of defects they are. These are usually given as codes that are used throughout the contractor providing the CCTV, and they use those codes to create reports. It is considered a simple technology to use. It is safe due to not requiring entering confined spaces, and it can be very cost effective, especially when you've already made those kind of upfront commitments to the infrastructure of using CCTV. So this is what the inside of some pipes will look like using CCTV. As you can see, you can establish, how well a collection system is running with the water level. You can identify big cracks. You can identify unusual infrastructure, such as taps that are pushed too far into the system. This type of technology is useful at maneuvering through bends and stuff like that and corners of wastewater systems. You can identify offsets and even some unusual chemicals or things like foaming buildups, which can also be exacerbated by, as you see in that last picture on the bottom right, what looks like an offset pipe where roots can come in, sand can come in, chemicals can come in, or these kind of chemicals that are leaking may just leak out of the system. The other type of monitoring technique that we want to mention is flow monitoring. This is the process of measuring the rate and volume of wastewater moving through a sewer system and the pattern that kind of forms. It helps utilities understand how the system behaves under different conditions and helps identify those unusual flow patterns to determine problems like blockages, infiltration, or overflows. It is typically done by installing a variety of flow meters and level sensors that are installed in strategic locations to track things like flow rates, peak flows, diurnal patterns. A lot of times when you monitor the flow for issues, those issues are based, or identifying those issues are based on the presence of sudden spikes, drops, or surges of flow monitoring. And those can be identified as things like inflow and infiltration, those blockages, and hydraulic bottlenecks as well. This can also be done with ultrasonic, area velocity, and wear flow meters. Those are the common types of meters used, meters or sensors. And typically the data that's collected is recorded and transmitted to a central system, such as a SCADA system, or it can be downloaded manually. Now, a lot of advanced systems have begun using AI that can analyze irregularities and even recommend areas to inspect directly through CCTV. So it's kind of like an ongoing field that's improving and becoming more of a useful tool. We also have smoke testing, which I mentioned in the I&I section. So smoke testing is a method used to detect defects, illegal connections, infiltration, inflow, things like that in the sewer collection system. As you can see, this kind of process involves blowing non-toxic, visible smoke into the sewer lines and observing where the smoke escapes. This is accomplished by attaching a smoke generating machine to a manhole or clean out to force that smoke into the sewer system. Smoke either travels through the designed sewer pipes exclusively, or it can travel through openings that are not part of the original design. So using sewer maps or no knowledge of the sewer system workers can walk through the area and look for smoke escaping from things like storm drains, yards and lawns, building foundations, roof vents, and crack in the pavement, which is some of the examples that we're showing here. These are just kind of lawns and buildings and stuff like that, but you can see the smoke coming out of the ground where they weren't supposed to, which indicates there's cracks and leaks, and this may be the site for I&I, and can even be once you use this kind of tests to do things like CCTV, you can establish if there's full collapses and stuff like that in the line. And this is also a good tool to use for illegal connections. If, say, the smoke testing reveals lines that are not matched up to your mapping system. Some other quick inspection methods are things like dye testing, which is used to trace flow paths and confirm that suspected cross connections or infiltration sources are present. This helps for locating unwanted cross connections. To do this, utility workers will pour or inject non-toxic dye into a fixture, storm drain, or roof spout, or even surface area, and observe if it flows into the collection system where it should not be. Now, this is important because it can confirm those extra sources of flow that contribute to hydraulic overload and pipes exceeding their design capacity. Another popular technology that's increasing in popularity is acoustic inspections and sonar inspections, which are non-invasive methods that rely on sound waves to detect things like blockages, sediment buildup, and structural changes inside sewer pipes. Those are a great tool when you have limited visual access to the pipe. So in this type of technology, you can use, they use a special microphone and sound transmitter to sound waves through the pipe to measure how much sound is blocked or absorbed. So if you have a microphone upstream in a manhole and you have that receiver downstream, and when you create some sound waves for it, and there's a low sound return in that microphone, it indicates there might be a blockage in the system. Now, sonar inspections are also similar to this, except sonar devices send sound waves through water and are usually good to use in submerged pipes to identify defects in the system and what could be causing them to be over capacity. So we've talked about what type of issues we see in the collection system, and we've talked about how we inspect for those issues. So let's talk about how we actually can correct or address those issues. So like we kind of mentioned earlier, to address obstructions, this is kind of just the same kind of slide. You have your routine cleaning, you have your inspections, you have a public education, and then that's for, kind of all obstructions, especially debris. And then for roots, you have your hydrojetting and mechanical cleaning, which is how you clear roots. You have your chemical treatment, and then you have your whole pipe replacement and repair. So I just wanted to kind of retouch upon that and kind of show some of the debris and kind of, what a collapsed pipe might look like from CCTV. So before I get into more maintenance, what I want to talk about is the idea of the different types of maintenance that we might perform on a collection system. And these two types are preventative and emergency maintenance. So preventative maintenance is defined as scheduled, proactive work aimed at reducing the likelihood of system failures and extending asset life. Some characteristics of this type of work include that it reduces emergency incidents and long-term costs. It improves system reliability and regulatory compliance. And then some examples of preventive maintenance would be things like routine jetting and cleaning up the sewer lines to prevent blockages, scheduled CCTV surveys to identify cracks, infiltration, or root intrusion, things like a grease trap inspection, program for food producers helps prevent fog buildup, pump station checks to ensure pumps and floats are working correctly to, again, avoid backflows and backups, and then finally manhole inspections to identify structural issues in I&I control. So those are the examples of preventative maintenance. And then you also have emergency maintenance, which is unplanned, reactive work that tends to be performed in response to a failure or urgent issue that poses a risk to public health, safety, or the environment. Now, some characteristics of this emergency work is that this type of work tends to happen suddenly and without warning. It is typically more costly than preventative maintenance due to extra labor, including things like overtime, extra equipment usage, and sometimes even regulatory fines. It can also be emergency work can also be disruptive to normal service or operations, and a lot of times is even due to a lack of regular proactive maintenance. Some examples of this type of maintenance would include repairs for collapsed sewer pipes, which can cause backups into the streets or nearby buildings. Uh, there can be bypasses in response to pump station failures, uh, and the removal of blockages caused by those excessive grease, debris, and roots that cause those SSOs. And then the last example of emergency maintenance is manhole replacement. Those can go missing due to traffic. They can be broken due to construction. They can go missing due to storms when they're washed away, and people even steal them. Really, the overall idea I'm trying to get at is that while emergency maintenance is unavoidable, and there will always be situations where reactive work is required, the best place to keep overall maintenance costs and avoid excessive emergency situations is to develop a consistent, well planned out preventative maintenance schedule. Now, some of those types of maintenance we'll go into now. So the first one is jetting or hydraulic cleaning. So high pressure water jetting, which I have mentioned, is known as hydraulic cleaning in sewer systems, is the process or method used in sewer systems to remove debris, grease, sediment, and other blockages from the sewer lines using those high pressure water jets. It is one of the most common and effective techniques for keeping sewer systems functioning properly. This process utilizes typically a specialized truck or vehicle attachment, which we would call a jetter or combo unit, that is equipped with a water tank and a high pressure pump. So that pump is attached to a hose and a nozzle, which is inserted into the sewer line to break up blockages. This is possible because these nozzles deliver water at a high velocity with pressure typically between 1,500 and 4,000 psi. Now, there are many different types of these special nozzles, but for the most part, they fall into the category of pushing water forward to break up blockages, or backward to propel the hose and flush debris. And then also, some hoses push water outward to scour the sewer line and kind of get rid of those buildup accumulations of obstructions that can kind of build up on and coat the outside of pipes. Now, after blockages are broken up, the debris should be removed so that it doesn't just reaccumulate downstream. So typically, along with jetting, you have a vacuum truck that is used to suck up the debris at the manhole downstream, or the wastewater facility can also handle these types of solids as long as they're notified that they may be receiving slug to treat. Now, finally, after cleaning, CCTV should be utilized to verify that pipe conditions are good and ensure that all obstructions have been cleared. So this is an example of what those nozzles may look like. As you can see, you have water pushing forward and water spraying backwards in both of these incidences. So those are some of those specialized nozzles. Similar to this, we also have mechanical cleaning. So mechanical cleaning in sewer lines are methods to clean sewers by physically scraping, cutting, or pulling debris out of the sewer pipes that are using specialized mechanical tools. The most common example of this is rodding, which uses steel tools that rotate mechanically or by hand. Some examples of these are in the picture to the right, which are from the Sacramento book. So these shows tools that kind of corkscrew through, which would be an auger. You have examples of cutters that maybe work flush against the pipe and will cut roots. Those are called root saws. Now, these can be either electrical and powered by machinery, or they can be hand rodders, which are typically used to access difficult lines. A lot of times, this can also be combined with jetting technology to flush the debris that's kind of cut away. Now, jetters, you kind of insert downstream and you move them upstream, so kind of against the flow of water. For rodding, you typically direct them upstream to downstream so that you don't kind of push up and cram debris more solidly against flow. And then two other examples of mechanical cleaning would be things like pigging or bucket machines. Pigging are snuggling fitting, typically giant plastic or rubber or inflatable tools that also scrape the sewer and kind of pull everything along the sewer till they can be pulled to a manhole where they can be removed. And then buckets work similarly, but it's a bucket that's being pulled by a cable through the lines. The next form of cleaning that we tend to see is things like chemical cleaning. Chemical cleaning uses chemicals designed to target grease, roots, scale, or organic buildup to remove them from the sewers. This is typically applied by pouring, spraying, or injecting chemicals upstream of the blockages, and then collecting them downstream, or monitoring to make sure they don't upset the plant. Examples of this would be things like degreasers, root control, those kind of foaming herbicides that we mentioned, descalers, biological enzymes. Now, a lot of times these can be effective for difficult areas, but are not gentle on sewers and should be taken care when using these so you don't contaminate the environment or put individuals and users in harm's way. Now, a lot of times these are used in combination with mechanical or hydraulic cleaning because you use these to like soften up grease or soften up biological hazards. So those are the main forms of cleaning, but we do have kind of different things that need to be cleaned up. Some example of this are things like fatbergs. These are large obstructions that result from fog, or fats, oils, and grease. And typically are heavy from food producers. They are typically removed from a combination of standard cleaning techniques, like we've talked about, chemical, jetting, rotting, vacuuming. Now, in older systems, really large systems that have been accumulating grease for years, sometimes they even require divers to jump in and clear out these types of obstructions. The most effective way that people find to address fog or grease bergs in your system is to have an effective fog program that includes things like monitoring and enforcement and installing the correct infrastructure. And I will talk about a little more about that in a little bit. So those are the forms of inspecting and kind of cleaning. Now, in the event that the collection system completely starts to fail, or it's just becoming more problems than those inspection or cleaning are worth, you would have things like a full repair. There are a couple different types of repairs that are used. There is your typical traditional excavation and open cut repairs, where you excavate the ground, remove the pipe, replace it, and ensure that it has correct bedding and stuff like that, so it doesn't shift, and the pipe is you have a brand new pipe in place. Some modern ways of replacing pipe are things like cured in place pipe, pipe bursting, slip lining. So cured in place pipe, you actually put in a liner that has a resin that is resin saturated, and you allow it to cure in place to kind of put a new pipe in the old one, which tends to work when you have an oversized pipe and you kind of have the room to decrease the capacity. Now, pipe bursting and slip lining are similar, where you have pipe bursting where you have a big metal head that breaks up a pipe as you pull it through and replaces it behind it using the old pipe as a guide with a new pipe that's pulled behind it, like I said. And then slip lining is similar to this, except you tend to drill through it and insert a smaller pipe into an existing one. Now, for pipe repairs, you can also have things like fiberglass or resin patches, which are applied internally, which are supposed to stop those obstructions from spreading and kind of give you a little more lifespan to your system in those segments. This is what kind of pipe bursting might look like. You have that big, long black pipe that's going to follow the metal head. Then you have slip lining, which you have that saw device, which is going to cut up the bigger pipe and allow you to install the smaller one inside it. We mentioned earlier, we have our pipe sags. So in this instance, you would need to go ahead and replace that pipe. So you clear the debris, remove the section, and add a new section where flow is allowed to proceed. Now, in these types of replacements, a lot of things, you need things like trenching. We've mentioned a little bit about excavating, and I'm sure many of you are familiar with it, but I wanted to mention a couple of details when it comes to using trenching for maintenance. First, trenching is defined as the excavation, digging, or cutting of narrow channels for utility installation. The first step would be planning, locating utilities, obtaining permits to do the digging, and providing traffic control if necessary. You would do the actual digging itself and dewatering to remove any water that may be necessary. And then as you see in the picture, you may use shoring or trench boxes to protect your workers as they dig underground, and you want to avoid any collapses. And then, once you have your trench dug, you do your pipe replacement and make sure that you have sufficient backfill and surface restoration. Now, just like inspection, manholes can be a little unique to the type of way that these techniques are applied, but overall, manhole repair is very similar to replacing other parts of the infrastructure of collection systems. A lot of times, these are easier to see when it's necessary. It may be due to things like excessive deterioration, to increase the capacity of your system, to address safety hazards, and you see increased I&I. Again, you kind of assess the system. You prepare the surface by removing any debris, sand, or contaminants. You provide your structural repair, which may require things like trenching again or excavation. Or you may do things like grout, or just grout the cracks as a kind of patch. And then a lot of times for our new manhole repairs and rehabilitation, you want to add kind of corrosive resistant material or lining to protect that system in those kind of infrastructure investments. When doing your maintenance safety, it is also important to have standard safety practices, which we kind of talked about in our previous two collection system sections, but these are all similar to the hazards and safety practices that we see in the rest of our wastewater. You have your combined space hazards, which can lead to things like oxygen deficiency, toxic gases, limited accessibility. So when you're entering your confined spaces, you want to make sure to communicate with other employees. There's also things like traffic, which we kind of touched on a little bit earlier, but you want to make sure that you're using proper notification to the public so they don't run you over and things like that, or they know that they shouldn't be walking over manholes or lines and stuff that are being used. Usually use things like cones and signs to kind of notify that. You should be aware of those other common hazards that are associated with wastewater, like your physical hazards, and then also the ability to be exposed to chemical and biological hazards. And because you're working around a lot of equipment, you also have the hazards from the electrical equipment that we use. Okay, so that kind of wraps up our section on the maintenance, actually maintaining those when you have those issues in your collection system. The next thing we'll talk about is how you come up with kind of a standard program, system, or plans to address your collection system maintenance. So the first thing that you want to do to maintain a system correctly and efficiently is have a maintenance plan or schedule. These are used to organize routine maintenance, preventative, corrective, and emergency maintenance. So workers basically know who's doing what and when it should be done. Now, the schedule should prioritize high-risk areas to prevent rock blockages and overflows. And the schedule should be designed or should be based on the historical data of the condition of your system, age, materials used, and all the data you've collected throughout using the system. These types of plans or schedules can be calendar-based. Say you want to schedule something kind of based on regulatory or regular industry standards, or more of a condition based where you're kind of addressing each individual asset and deciding when that should be maintained. Also, these plans tend to determine communication procedures and data requirements. So the next section will kind of talk a little bit about the steps to creating a maintenance plan, and I'll provide kind of a bit of a brief template for what goes into a written maintenance plan. So the first thing that's always useful to create for a variety of different types of utility plans is give you your system overview. This kind of gives the basic information for the system, like names, addresses, who's responsible for what. Now, this can seem redundant or insignificant, but these tend to be really important when you're doing things like creating information that can be passed down to future workers and stuff like that. Then you want to tend to have as much information about the system as possible. This is where you would create an asset inventory, which would include things like an asset ID for everything in the system, location, pipe details, installation dates, last inspection dates, condition ratings, and connection components. A lot of times GIS and mapping systems tend to really help with this and show where and what is involved in the asset inventory. Then there's the actual maintenance and inspection scheduling themselves. These will typically include the type that's going to be done, the priority level of that, the results of any inspection or maintenance, who's going to be assigned to them, and when the next activity will take place. For inspections, you also want to have recommended actions and then photos and video evidence to show why things need to be done. To go along with a maintenance plan, it's usually good to have a good work order system, which can provide the task assignment and management and tracking system for your system. And a lot of times a work order system may be the bulk of maintenance plan in general. And then, some of these more advanced systems can also provide things like reporting and analytics, give you trends, budget forecasting, and even hotspots, which I kind of show in this kind of drawing right here as an example of a system that was able to kind of in red identify where their problem spots are for their system. Now, there are a variety of maintenance scheduling tools. You can use things like paper records. You can use your Excel sheets, which require you to kind of update manually, or you can use things like computer management software. So as you can see, I kind of have an example here of a calendar. This is just kind of a calendar view of a computer management system, which would you would use their asset template to put in your asset inventory. And once you kind of do the groundwork to create this, you're kind of able to just click and choose and put your maintenance and inspection activities in. The Southwest Environmental Finance Center, and I think we've even worked with some of you guys to establish some of these programs. But if you have any questions about this or interested in some of these, we'd be happy to kind of help you work with these and get these established. And there are even some free options. So with these systems, it's also important to have good mapping systems, which we've kind of mentioned. The best one to use for this is kind of our GIS, which stands for our Geographic Information Systems. This provides mapping and spatial information to allow utilities to visualize their assets. So a lot of times you can have the asset location and it will identify and provide information about it. These GIS maps will give GPS coordinates that can be used in the field and for field location devices to actually be able to drill underground and find everything directly. These mapping applications also provide useful data about the system, such as where flows are moving, which connections they may be splitting off from or connecting to, where access points are for maintenance, and then also environmental and regulatory zones so people know if there's any restrictions in those areas. We have kind of an example at the top right of what a map might look like for some sewer infrastructure, and then also some devices that are frequently used to create an accurate map or GIS system. So those are some useful tools. And then the last two slides I have are going to talk about some other types of programs that are used to effectively maintain a collection system. So the first is a FOG program. So FOG programs are designed to specifically minimize the impact of fats, oil, and grease from food producers on the collection system. The components of a successful FOG program will typically address your FOG producers, where you would have them install things like grease traps, which are specific tools designed to trap grease at the top of these devices at the surface of the water so that grease can be removed. You would go ahead and suggest best management practices for grease producers to follow so they minimize their grease that ends up in the system. And then there would be a documentation system so that they can make sure that they are disposing of those contents of those grease traps correctly. Another good part of these of these FOG programs are public education. These are your typical cool it, cap it, toss it campaigns, which kind of inform users of the dangers of fog and how to best handle it by letting it cool in a can, capping that can, and throwing it in the trash. You would also, in line with your inspection programs, be monitoring the collection system and nearby food producers to see if there be, if there's unnecessary fog building up in the system. And then along with those programs, you typically have some enforcement that may issue violations and penalties and have compliance regulations for the food producers and stuff like that. Then the last thing that I want to talk about for special programs is the SSO teams. A lot of times to properly document and plan your response and also notify regulatory personnel about SSOs, you want to have a whole team kind of dedicated to that. This may be collection system people, wastewater people, monitoring and inspection personnel as well. A lot of times you want to have a detection and notification system. This may be things like alarms in the system that notify your SCADA. This would include regular inspections to identify areas of the collection system that may be most at risk for SSOs, and then a system for the public to notify you when they recognize flow and overflows in the streets, which can be dangerous to them. The type of procedures that would be involved would have, containment of the overflow to make sure that it doesn't spread, cleanup to make sure that it's properly disposed of, and disinfection so there's no lingering pathogens in the SSO site. And then, like we've been talking about with a lot of this other stuff, data is super important for this. It can be utilized to create, kind of those hotspots that may be most likely to have SSOs. So that wraps up our section. I know we're just a couple minutes late, so hopefully we're not too bored with it, but I'm happy to stay on for a couple minutes and answer questions if anyone has any. Also, feel free to put them in the chat. Here's my information for anyone that's interested. Let me check out the chat. All right. A bunch of good mornings and buenos dias. Good morning, everyone. A little bit late, but if anyone has any questions, I'll stay on for another couple minutes. Otherwise, that wraps up our presentation, and I appreciate you guys following along today and participating. And I hope you have a great day. It doesn't look like anyone has any questions, so we'll go ahead and end here today. If any questions come up, feel free to email me or email the Southwest Environmental Finance Center. And again, this presentation will be sent to you guys here in within the next couple days, I believe. Have a great day.
Have a good one, AJ. Bye.
Thanks, Valeria.